Hello everyone. Today we'll look at distributed file systems. Um, the history of the file systems before 2000 before the year of 2000, there's a network file system NFS, so-called, developed by Sun Microsystems. So NFS allows multiple clients to access files over a network as if they were on the local hardware. Right now, this kind of environment is very, very, very common. And also, the hands-on, the lab that we are going to do, that is exactly the way that we could do. That was, uh, at the time, the new idea when I was a student, right? And also Andrew File Systems at Carnegie Mellon Universities running AFS. I still remember that I entered Andrew the file system. Um, um, it turned out that I broke in their Andrew file systems uh, from my remote Sun Microsystems. Well, anyway, so uh, so nationally it was investigated, but I did it. But anyway, I have been protected by the dean of my university, uh, although FBI was investigated. I think it was probably raised from Carnegie Mellon University. That's their defect. They didn't protect their systems well. After that, they made covers-based authentications. Okay, so before 2020, Google File Systems also available, like Hadoop distributed file systems. Recent years, lots of those things available. So we do a little bit of the exercises. Ours is not the one commercialized, but ours is simply that we could do at the school level. So I wanted to read those things, and today what we will do is actually simply this client-server architecture. Okay, you already set up Raspberry Pi TCP server and also client. Client runs on your laptop, and at server side there's a TCP Python server programs running, and your TCP server needs to do some of the things that you will request. Okay, what we are trying to do here, rather than accessing any particular file systems on your Raspberry Pi, but we're going to ask your Raspberry Pi TCP server to execute Linux operating systems, because that is simple, right? And all of you could do on the same platform as far as you are working on Raspberry Pi. Okay, so that is fair. And also at your client, you can simply request any kind of the Linux command. Then you can request, hey, TCP server, would you be able to execute my Linux command at your Raspberry Pi operating systems? Then your Raspberry Pi operating systems execute the command that you send to, and whatever the outcome from Linux command executions will be returned back to you. Okay, so that type of things will be done. The other kinds of architecture is the peer-to-peer, fully distributed systems. So ours is client and server. The roles will be played. This is more commercialized, cloud-based architecture. But in this class, we're working on all most of those, right? Okay, so the other things I wanted to read, and I'm going to give you a demo on your Raspberry Pi. TCP server is running, and on your laptop, TCP client can run. All right, so I'll start my PowerPoint presentation. And now I have Raspberry Pi running and VNC. I'm going to connect my Raspberry Pi through the VNC connections. So I have here VNC. Okay. So in this Raspberry Pi, I can open up the terminal, and remember that I have a project 24, and now TCP server program sits here. The program like this. Okay, so it has actually it imports a socket and server process. If you want to do multi-threading, then you need to do this. So in this program, a little bit of multi-threading is executed. And the class TCP server is defined, and there is a object constructor and bind module and talk, so we can listen and accept, listen the client request and accept it. And then there's a command. Well, assumption here is a client send to the server only the Linux command. In this program, the program does not sanitize the request from the client side. Okay, so that is a big assumption. For cybersecurity reason, you should not accept all the commands, right? But this is our own emulation. For the purpose of this hands-on lab is not for the protection of our network or infrastructure, but rather we want to make it operable. So how client can request a proper command, assuming that the server can accept it and execute it. So command is received, so we call that command. And on this server process, we can run that command. Command that on shell, and we capture the result, outcome. And the result comes into here. This is called the result. We can take it to standard output, and we call it output data. And print that output data, and at the same time, this can be, the output data can be written here, and at the same time, that output data can be returned to the client. Over the course of the network, the data needs to be transmitted, then data needs to be encoded. Because it is encoded, when you receive it, then you have to decode it to make it readable. Okay, so this is the server side. And if you look at this, then you may be able to see the IP address. So remember that 192.168.68.140. And my client program here. So I'm going to push this a little bit here and make it smaller like this. And this client, you don't need this actually. So import the sockets, and we define the class. So initialize to connect to the server. So connect. This is a host name and port number. Host IP address should be the IP address here that we looked at, and port number should be the port here, 2545. And then at the client side, we ask the user to enter the Linux command, but the prompt statements that I wrote here is simply requested to your Raspberry Pi. Then if you enter that, then that message can be encoded and sent to that object. Object is the socket objects that is connected to the server. So to the server, that message is sent. Then after the message is sent, then server process it and return back to you. Then you can receive it and decode it and print. Okay, that's what this guy can do. So don't forget, this program should run first. Python, I believe it is called, I forgot. So Python TCP server, that should be running at the server side, your Raspberry Pi. And then on your laptop, this is Paizo. I'm going to save this and Paizo run. That RPI, the IP address that I made that here. Copy that, and port number is 25545. Then we can request, say ls minus l. Then that is the current. Remember that on this current, we have only one file, right? But I want to see this file, the listed, the directory content. So when I hit enter, then at the server side, this guy printed. This is the result of ls, jun, and only this file is available. That is returned here. The total for this is returned, right? This is exactly the same as that one. So if you want to do more, then you can do yes, and then you can do ls minus lt and dot dot. When I do dot dot, then it can go up, one level up. Before we get into this project 24, so we need to move back up to the parent level of a directory and see the list of files. Okay, that's what I ask it to do. And then T means I want to sort it by the time. So when I request this, then it returns at the server side. This is recent ones. This is sorted by the time. The recent one is project 24 and whatever those files. And at the same time, at the client side, it is returned that way, right? And when I say no, and it stops. All right. If I want to show that to you when I back up the parent side, ls minus L, then that is exactly the same one as the one that we looked at. So ls minus LT, then it should be the same as this one, right? LT. Right there. All right. That's it. This is the distributed file services. Yeah. I wish you can include a little bit something like this on your project. All right. Thank you. See you later.